or PCR for short, is a method used to amplify targeted portions of a DNA molecule. The reaction must be prepared using the correct reagents. First thing we need to add is water and a buffer, which will set up an environment crucial for the reaction to occur. Next, we add magnesium chloride. This supplies magnesium ions required by the DNA polymerase later. Now we add deoxynucleotide triphosphates. These contain the adenine, thymine, guanine, and cytosines that will become the new DNA molecules. Now we can add the primers. Primers are short oligonucleotides which bind specifically to target DNA. In our case, we'll be using a forward primer which binds upstream to the 16S rDNA locus and a reverse primer that binds downstream to the 16S rDNA locus. In addition to adding specificity, primers also offer a free 3' hydroxyl group, which the DNA polymerase needs to synthesize new DNA. Speaking of the DNA polymerase, we now will add Taq DNA polymerase, which is a thermostable DNA polymerase that we will use to synthesize the DNA in this reaction. Mixture is complete, I will distribute this mixture into a series of tubes containing DNA isolated from the colonies that we got on the first day of class. In addition, I'll distribute this mixture into a positive control tube containing E. coli DNA, which we know will amplify, and to a negative control tube containing only water to ensure that our reagents are not contaminated. It's time to put those reactions in the thermocycler. Refer to the PCR video on the MCB300 website for what's going on at this step. We'll come back in a couple hours to check on this. The thermocycler is finished. We've taken our PCR products and loaded them into an agarose gel for gel electrophoresis. Gel electrophoresis is a process that separates DNA molecules by size. In the first and last wells, we've added DNA ladder, which is a mixture of DNA molecules of known size. In the rest of the wells, we've added our samples from before. Now all that's left to do is to put on the lid and start the machine. The DNA being negatively charged will migrate towards the positive pole, which is situated at the bottom of the gel. All we need to do now is wait 45 minutes and come back to visualize. Now that we've run the DNA through the gel, it's time to visualize it. The gel has been stained with ethidium bromide, and wherever there's DNA, it will fluoresce under UV light. Now as we look at the gel under UV light, we can see on either side the markers which have separated nicely. Also in the first lane, we see the positive control, which looks to be the right size. In the second lane, there doesn't appear to be any DNA, which is good because that was our negative control. The rest of the lanes show a nice band for the 16S rDNA at around 1500 to 1600 base pairs. We'll take a picture of this for you to analyze later.